Good day. Today we're going to be doing a start to finish drawing on this model that you see on the right hand side of your screen. We'll keep that posted up there so you can check the dimensions as you go along, and I'll also link to a drawing at the end of the video that you could then post up or take a screen cap of. Alright, so what we're going to do is in Solidworks is we're going to create the part, and then we're going to create the two-dimensional drawing and develop it from that point. So to get started, we'll hit the home button and we'll start with a part development. And as you know, when we start with a part development, our first step is to decide how we're going to sketch out this part. So if you take a look at the object over here on the right hand side, we've got basically three different directions. We can take the direction where we've got the slot on the bottom cut out. We can take the direction of seeing like an L-shaped pattern here on the side, and then from the top we'll see two holes and a general rectangle overall. Well, the only real option is the L, because it's going to give us the most definition for the front view. And that is always the key, is pick the view with the most definition of the shape, or the hardest to create, because you want that to be your first one to start with. We'll pick the sketch button, and we're going to work from the front plane on this particular drawing. And on the front plane, we'll start at the 0, 0 point, and we'll sketch out the L shape. So we'll start at the anchor point, bring it out. I'm not worried about what sizes the dimensions are. We'll deal with that in just a minute. But the whole idea is that we need to sketch out the L shape. And you're thinking, well, but how are we going to handle the arc on the top? We'll deal with the arc on the top as part of our drawing environment, but we don't have to draw it as a circle. We don't have to draw it even as an arc. We're going to show you a different way to create that. That's also extremely accurate. So here's the shape that you would see looking from the side. The arc itself still looks like a rectangle, and we've got our other objects there. So looking at the dimensions that we have, and we can probably magnify a little bit here to get the dimensions. I'll increase the screen size of our object just a hair to bring all the dimensions into play. And then we can see that overall the height here is 2 inches. So our first dimension that we're going to apply is a 2-inch dimension here at the bottom. And even though we sketched it out and it was pretty small, the dimension itself will update and we'll accept it. And that becomes our 2-inch dimension. The other dimension that we have here is a 6-inch dimension across the bottom. So we'll pick Smart Dimension, pick the bottom, and we'll make this 6 inches. Now that just kind of wonkied the whole drawing up based on the overall shape itself. So we've got a couple of options that we can deal with. Number one, the easiest way is just to hit the undo button. We'll come back and add that 6th dimension in just in a minute. What we do need to keep in structure is what the width of the back happens to be. And that says that it's 1.25 here. So we're going to go ahead and add in this smart dimension here and make this 1.25. And what that does is that holds the shape of the part. Now, if we were to choose the OK button or the green check mark and come back and change the 6th dimension, notice that the shape now keeps the part design. The last dimension we have to deal with is the height, which makes it kind of tricky because it doesn't give us an overall height, and we've got an arc here. So the arc says the radius is 2.75, and that 2.75 goes to the center, which then goes 3.25, which is kind of weird because that really doesn't look like 3.25. I bet you that's supposed to be 0.325, but we'll go with what it says because that's what the drawing calls for. So 3.25, so 2.75 plus 3.25 is 6 plus 2 from the very bottom of the part. So that's 8. So we'll go ahead and add a smart dimension on the back of this for 8. So sometimes you have to go and add the dimensions up to get the overall height. So now that we have the dimensions set, notice that there are no blue lines left. All the lines have turned the dark color. And that means that it is configured and constrained properly. So from here, we're done with our sketch, our basic sketch. So we'll hit the jump back button up here on the upper right hand side and jump back to the part level. And the feature, or jump out of the sketch ultimately, and our feature is going to have an extruded boss base. All right, that sounds cool. What we're going to do is we're going to look at this in a orientation that is a perspective. So we'll just kind of look at a angled perspective orientation here, and we can rotate it just a little bit by holding the wheel of our mouse down. We'll then use the extruded boss base as our tool, and we can extrude in whatever direction we choose to. So we can go negative or we can go positive. And since I rotated it, we're going to go in the positive direction, and notice that we can choose either one. And so we'll rotate in the positive direction, and the distance here is going to be a total depth of 5.50. And again, that's listed here on the bottom of the part. And we'll hit the enter key. So that's now our part, and we'll choose OK. So far so good on the part. We created the sketch, we created that. Let's talk about how to get this rounded top, or the arc across the top. The easiest way to do that is through the fillet command. And most people don't think about that. Most people would draw a circle and then trim half the circle off and then extrude half that circle. But realistically, what we did is we took the overall dimension and created that part, and now we can use the fillet command with a radius of 2.75, and we can apply that 2.75 radius to the edges. We want to radius the edges of the part, and I want to get rid of that face and just do the two edges. So if you mispick something, all you do is you go into the window, highlight it, and hit the delete button to have it go away. And we choose the OK button, and it should fillet the top perfectly, which it does. So that was pretty cool. So that's the fillet tool, and we use the radius. Now again, it knew exactly that the 2.75 would create a perfect radius across the top. All right, now we got to deal with the slot in the front of the part. So to deal with the slot in the front of the part, we're going to have to create another sketch and extrude that feature to cut out that bottom. So we choose the sketch tab, we choose sketch, and we put the sketch on the front of the part. That's the easiest location. Now with that, instead of drawing 4 lines, I'm going to use the rectangle tool. And the reason why I use the rectangle tool is that we're only dealing with a portion of the rectangle that's going to be used to cut it out. Okay. So now we have to deal with the depth, and now this is where the smart dimensioning comes back in. Well, the depth of the cut is 1 inch. Notice that it adjusts it accordingly. Now the width of this part is, the width of the cut is 3.5 inches. Not bad, I was pretty close. Okay, now here's the tricky thing. So 3.5 from 5.5 leaves 2. So to center this, we're going to need a dimension from one edge and make that 1 unit. And boy, was that close. So it was almost perfectly centered up. Now the overall height of this is not that critical. All we need to worry about is the depth, the width, and that it's centered. So dimensions have to be feature size and feature position. Those are the two dimensional sets that you have to worry about, feature size and feature position. Again, we'll rotate this slightly so we can get the three-dimensional view. We'll choose OK on the dimensions, and we'll say we're finished with the sketch. With the Finish Sketch button, we'll go to the features. So instead of extruding it, what we're going to need to do is cut an extruded part. So we'll pick Extruded Cut, and we're going to extrude the cut all the way through instead of blind. We'll just say we're going to go through everything. We're going to go through the whole part. And what that does is that's going to cut it all the way out of the back. And we choose the OK button, and it removes it all the way from the part. Pretty cool. All right, so the last thing we're going to deal with is holes. Now there's a couple of different ways to deal with holes. I'll show you the hole wizard to create the hole on the face for the back. On the base of the part, what we're going to do is we're going to locate points first and then use the hole wizard to apply the holes to those points. I find that easier in a multiple location same size hole scenario. If you take a look at the drawing, it says there's two holes at 1.25 inches. Okay, so there's two holes at 1.25 inches and there's another 1.25 inch hole on the back. So all three of these holes are exactly the same. The difference is since they're on two surfaces, we have to do it separately. So we're going to go ahead and put a sketch on the bottom here, on this base. And that sketch on the base is going to give us the ability to put a point. Okay, and that's what the point command is for. So we'll pick a point. And where does the point need to be picked? Well, we're going to ballpark it. We don't know exactly, but we'll lay it out here in just a second. We're going to pick 2 points. Make sure they're along the same horizontal plane. Now we're going to smart dimension them. So the smart dimension says that this one is 2 inches from the front. The second one is 2.75 inches from the front. Both of these are along the line of symmetry, or the center line, which means the distance from the edge of the part to the center line is 2.75. How did I know that? Well, the radius value is 2.75. That created a perfect radius across the top. And the 5.50, half of that value, is 2.75. And I want to make sure that both of these points are 2.75, because not all the time do they stay aligned. So I'm going to do it to each point. All right, so now we've got our 2 points positioned and located. So again, feature size, feature position. This was all about feature position. We're going to go ahead and jump out of the sketch tool, rotate a bit, and you can see that we have our data points. We're going to use the feature tool to create a hole. So I select the hole wizard. And it gives us a lot of options. We're going to go with a standard hole that's drilled. The size of the hole here has to be 1.25. So we can scroll down to 1.25, or we can just type it in. Now fractional drill sizes might be too small. So we can just choose all drill sizes, and then we can just type in or scroll to 1.25. And you'll notice that there's a variety of different options here based on what you're actually drilling. We could also choose different settings within this. And I'm surprised we don't go above 1 inch. We maximum above 1 inch is the maximum drill size that we're able to get. Interesting. So if we can't do it this way, we'll have to draw circles and then extrude the circles. I always like using the hole tool, though, to accomplish the tasks. Pipe trap, screw clearances, tap drills. It says all drill sizes. We should be able to go bigger than 1 inch because holes actually are bigger than 1 inch at times. So it's interesting that based on the hole type, we can get different values that we're able to create the holes with. Okay, so interesting here. So if I do a drilled hole, it gives us those sizes. If I choose a flathead screw hole, we get different settings. And if we just choose all drill sizes here, I should be able to go bigger than 1 inch, but I'm not able to. So this is a slot, by the way. Okay. So since that's the case, we're going to have to draw it as circles and then extrude the circles instead of the drill hole sizes. It's unfortunate, but it is possible. I could do it as a tap drill, and it will work as a tapped hole. It will give me the ability to do 1.25 or 1 1/4 inch 12 threads or 1 1/4 inch 7 threads per inch, but that's not what we're looking for here. So since that's not the option, we're going to have to go to Plan B, and Plan B is to go back to our sketch. So we'll edit the sketch by right mouse clicking, and we can edit the sketch, and with the points we'll draw 2 circles. And what we're going to find out is that we got a problem. Because when we draw the 2 circles and we put the smart dimensioning on the circles, and if they're 1.25, they overlap. And that's not good, because the image does not indicate that they overlap. So ultimately, what we can do is take this distance instead of 2 inches, keep this distance or keep the 2.75 distance, move this distance to 1.25 to separate the holes, so that way they have some separation. This would be a time that if you were actually involved with an engineering project, you would go back to the engineer and get their authorization to make any changes such as we just did. You also see that I'll drag these 1.25 dimensions, just left mouse click and hold, off the part so that way they look accurate. So any changes like this type of a scenario where things don't work out based on the values that are on the drawing, you want to go back to the engineer and get their approval before you make any modifications, any final modifications. All right, so we've got 2 circles. We'll have to extrude these 2 circles, so we'll jump back out of the sketch and rotate it slightly, and we'll do an extruded cut, and we'll pick the 2 circles. Let's see here, what happened to our 2 circles? Extruded cut, we want to pick both of these, so here and here, there and there. I use the control key and add 2. I should be able to. Then do an extruded cut, and there we go. So what I did was I held down the control key on the keyboard when I selected the edges of both circles, so both circles were selected, and it's going to cut those 2. So I selected them first, then I picked the extruded cut, and I'll check the OK button. So the same thing's going to happen on the face of this, is I'm going to have to draw a circle and then create a hole from that circle. So we're going to go ahead and apply a sketch to the face of the drawing. We'll draw a circle. Now that circle is going to be concentric. Now notice what I did here is I highlighted the edge, and it gave us the center of the circle. So I now know that that's the center point that I need to work with. And then I can go ahead and edit this circle value and 1.25. Same scenario, we'll rotate slightly, accept that dimension, go back to features, extrude cut, highlight the edge of the circle or pick the circle, and choose OK. So now we've got our part created. Okay, those are all the features. We want to hit the save button, so we want to do a save as. We always do a save as. And so with the save as, we'll do a save as. We'll save it inside the 1301 class. We're going to call this start to finish. And it's going to be saved as a solid part. We'll hit the save button. Perfect. Now that you've saved that, you can also, if it requires you to save it or submit the drawing as a PDF, you can do a save as and then change this to a portable, not a portable network graphic, but a Adobe portable document format, a PDF file. So you can actually save this image as a PDF file if it requires you to submit it as a PDF. So that's also an advantage for you working in the part environment. So it's all under the Save As tool. Our last thing that we're going to do here is we're going to create it as a top, front, side drawing. So to do that, we're going to go ahead and create a new drawing. So we can hit the New button. And one of the nice features is if we hit the down arrow next, it'll say make a drawing from the part, which makes life so much faster and easier when you're working inside Solidworks. As opposed to starting a new drawing, bringing the part in, or selecting the part, we can make the drawing from the part. So we'll pick that. This one's going to be an ANSI inch drawing, so inch ANSI, and we'll choose OK. With the inch ANSI drawing, it's going to come up and give us some basic information associated with our drawing. We can customize and create our own title blocks and so forth. The sheet format, you can edit the sheet format, which I did is right mouse click here. And right now the sheet is an A size sheet. We can go ahead and edit the format of the sheet, which means by editing the sheet, where's our window here? Edit sheet format. We can delete out anything that we don't want to, like if I wanted to call this TS drawing, I can edit the text here as opposed to having whatever the default happened to be here, that kind of thing. Delete imagery, all that kind of stuff. So what you're doing here is you're basically customizing the title block with the sheet format. If I right mouse click on the sheet, I can edit the sheet. And editing the sheet allows us to edit sheet format. Okay. Editing the sheet allows us to change any modifications to the sheet itself. And so our start to finish drawing, and all I'm doing is right mouse clicking on each one of these annotations and then the sheet and sheet format. So edit the sheet format, we've been there already. We can add additional sheets. We go to properties. This is where we can change the sheet information. Like if I wanted it to be a B size sheet instead of an A size sheet, it defaults to an A size. We'll go ahead and apply the changes. And again, sheet properties is where I'm at. We'll apply the changes. Yes, we'll go ahead and take that out. All right, so now we're on a slightly larger B-size sheet, which makes it a little bit easier for us to work with. Now there's tabs across the top again. Our drawing tab will allow us to bring in our model view. And that model view is our start to finish drawing. That sounds good. That's what exactly we want to do. And what we want to do is bring in our start to finish drawing. Select part of assembly to create the view. Bingo. So I double click on that and it brings in my view window. We don't know what the view looks like yet, but once we click on it, it will show us. So we got the view. We can create a top view. And instead of doing a right side view, because the right side view, if I was looking at this way, we'd see a whole bunch of hidden lines, which wouldn't be good. So we're actually going to do a left side view. And then we want to do an isometric view too. Oh, that's a good isometric. All right. And once I like all those views, we'll right mouse click and save those. Now the cool thing is that we can move these around. So if we want to move this around to give it a little bit more space, we can do that. As long as we keep the orientation consistent, and the software will make sure that happens. I'll go ahead and put this one up in the upper right hand corner. And the cool thing is that if I right mouse click on the edge, I can if I click in this particular view window, you can see it's highlighted. I can change it to a shaded view. So it gives that extra emphasis on the drawing environment. Now, each one of these views, we have hidden lines, or we have potentially hidden lines, especially in the front view and in the top view. So we're going to right mouse click on the view, and one of the options that we have available to us is to add the hidden lines. So if we right mouse click, it will pop up a window, and it's not on the list. There's this little option here that says hide and show edges. So if I hide and show the edges, it'll allow me to select those. Nope, that's not what I wanted. Sorry. Sometimes I mispick things. Let's right mouse click, and we'll go to properties, and the properties show hidden edges, and we'll apply and choose OK. And I want to go ahead and show those hidden edges. Let's double check on this. Drawing view. I'm looking on the left hand side here to make sure. Projections, automatic view, more properties. Yeah, show hidden edges. The hidden edges file features are shown when the display mode of the drawing view is in hidden lines removed. So what it's telling us is that in here, it's in the hidden line remove. We want to show the hidden lines. So we want to make the hidden lines visible. So on the left hand side, when I click the view, we want to choose hidden lines are visible, and bingo, the hidden lines are visible. Same here. All the views now update. Since that was the first view that I placed, that's the parent, the child views update accordingly, and you can see that the hidden lines are now located in all the views. Sometimes you run into that, click the wrong thing. But you'll notice I don't edit that out. If I make a mistake, we work through that mistake. All right, so now we can put dimensions on the drawing. As I mentioned earlier, the dimensions, we can use an automatic dimensioning process. I'd prefer not to do that. We'll use the Smart Dimensioning tool again, and we'll start by putting the 2-inch dimension in, and then we can magnify the window here. We can put a 1-inch dimension in, and then we can do the 3.5, and if you pick the 2 edges, that does the 3.5. What I'll do is I'll do a long dimension here for the 5.5. And notice that I'm taking all the dimensions off the edge of the part. And so each of the drawings have dimensions that are necessary. And for this 1.25, I'm going to put an X2 here at the end in just a second. So I just keep adding dimensions to the overall part itself. Notice that I try not to get the dimensions too close to each other, but I want to apply the dimensions close to the drawing that they're situated in. Again, we need to do size and position of all the different features. So now I'm going to do a position dimension for the holes. Well, that's interesting. So that's along the center line. That works out okay. This one's concentric. That's okay. That's there. That's the depth. Got the cut there. Need a dimension here for the smart dimension here for the width. And again, smaller dimensions go closer to the part. Larger dimensions go farther away. We don't have to worry about the overall height. That's pretty well dimensioned at this point. I am missing, that's along the center line here, so we're okay there. You know, I could put a dimension in off to the edge there, but that's again not a critical dimension. So at this point we're pretty much finished with our dimensioning. I said that I'd show you the editing capability, so I'm going to go ahead and choose the OK on the dimension. I'm going to double click, left mouse click on this 1.25 dimension. And if I double click on it, at the bottom, notice that it says mod diameter dim over here on the left hand side for dimension text. I'm going to add a capital X and a number 2, and you'll notice that it adds the ×2. So I'm right in that dimension editor, and I can choose OK. So those are the ways that you can do a quick edit. If you want to change the number of decimal places, you can do that too. Same thing in the properties. If I click on a dimension, we have properties. The number of decimal places is listed above. I can change the number of decimal places, and I can do that. If I do that early on, then all the dimensions will have the same number of decimal places. If I need to change 1 or 2 based on tolerances, I can do that also. All right, so that's it. Make sure that your name is on the drawing sheet. You can edit and put text in the drawing sheet. That works okay too. That would be under the sketch tools or under the drawing tools. You can add a note, that kind of thing. Save your work by hitting the Save As button. And what's interesting is when you hit the Save As button, it'll save it as the same name, but it'll be a drawing sheet and not as a part file. Now again, the drawing sheet should also be saved as a portable document format that you're going to send to your manager or your instructor or your customer. Those are the people that are going to look at the PDF file. They don't have to have Solidworks to look at the drawing. They can provide feedback to you from that drawing environment by just having that PDF available. Have a great day. We will talk to you soon on the next video. Bye now.